Hey, what's up, guys? This is Chung here. So today, let's take a look at today's daily challenge problem number 667, beautiful arrangement number 2. So you're given like two integers n and k, right? And you need to construct a list which contains like n different numbers, right? Integers from 1 to n, and obeys the following requirements. So basically, we have the difference between two adjacent numbers has to be exactly has exactly k distinct values, and if there are multiple answers, you can print any of them, right? So for example, if we have totals of length 3 uh, elements, right, and then the case 1, which means that we only allow one distinct values, right, between all those adjacent numbers. That's why we're gonna have like 1, 2, 3, because for 1, 2, 3, the neighbors, the difference between two neighbors are all 1, right? And this is the absolute difference, because 3 to 1 is also a valid answer for the in this case, right? Because this one, the difference is also 1. Okay. And then another example, right? So we have n is equal to 3, but now the distinct values we're looking for is 2. So in this case, we have to move around the numbers, find another permutation of this all three numbers. In this case, we need 1, 3, 2, because we have 2 here. The difference is 2, and here the difference is 1. That's why the answer is 2. Okay, and the range is like 10 to the power of 4, right? So obviously, we cannot find all the permutations and look for and find check the if that's a specific permutation can meet our requirements. Obviously, we have to find a way of construct this answer, right? I mean, to solve this problem, we just simply need to try a few more examples, because this one is not like obvious enough for us to see the patterns here. How about, let's see that the n is equal to 10. I think this is large enough, right? So let's say with k is equal to 1, right? So for this one, uh, when k is equal to 1, obviously the answer is what? It's 1, 2, 3, right? Until to 10, right? K equals to 1. And when k is equal to 2, what's going to be the which is the what is the one of the answer, right? So for this one, what we can do is that we can, after 1 here, right? I mean, we can put 10 here. Okay. So that the difference is 9 now, right? Because we're gonna use difference 1 as the base. So whenever we have like so when the k is equal to 1, we know, okay, so the difference we're looking for is 1, right? And when k is equal to 2, basically besides 1, we're gonna, because 1 is a base, because if we just print the remaining numbers in the either decreasing or increasing order, the difference is always 1. So that's why, when the k is equal to 2, based on 1, besides 1, we can add like another number, which in our case, it's like, in my solution, it's 9, between the last one and between the first number and the last number. Okay, now we have a difference of 9 here, right? And after 9, we only have one case left, right? So which means we're gonna print the remaining numbers. So it's gonna be a 8, 9, 7 until what? Until 2. And how about 3 here, right? So when k is equal to 3, we're gonna continue our construction here. So we have 1, and then we have 10, right? So the next one is we need another one, because the difference is 9 here, right? So the next difference we can get is 8, right? And how can we get 8? From 10, we need to print 2. That's how we get 8, right? And after 2, we only have 1 k left, which means we have to print the remaining numbers in order, which means we're gonna print 1, 3, 4 until what? Until 9 in this case, right? How about 4? So if we have 4 here, let's continue our construction. We have 1, 10, and 2, right? So we have difference. We have 9 difference, 9 difference, 8, and the next difference is 7, right? We can get additional a difference is 7, which means this one is 9, right? And after this one, we're gonna print the remaining again, right? So gonna be a 8, 7. This time we stop at 3. Cool. So now you can see a pattern here, right? Basically, based on the number of k here, we're gonna maintain basically. So I will maintain a left and right, left and right number. So the left is 1, the right is 10 in our case, which is n. So whenever the index we're printing is the even index, I'll add the left here, and then I'll increase the left. Now whenever the index is odd, I'll print the right number, and then after that I'll decrease the right, so that we can have 1, 2, and 10 and 9, right? So on and so forth. And then for the remaining ones, based on the based on the parity of k, you know, because when k is equal to 1, right, and then it means that we're gonna print the remaining in the increase. Sorry, when the parity of k is odd, which is 1 and 3, we're gonna print the remaining numbers in the increasing order. And when the parity of k is even, we're gonna print the remainings in the decreasing order, right? So that's everything we need actually, And with those kind of observations, we can basically construct our numbers, the final answers, for sure. And yeah, so I'm going to start the coding here. So at the beginning we have the answer equals to this empty, and like I said, we have left equals to 1 and right equals to n, right? So I'm going to construct the first part, right? Where's where the times we need to construct is the case time, right? So if the I is like odd index, right? So it's even index, we're gonna append the left, right? And after that, I'm going to increase the left by 1. Else, if it's even, right, I append the right side number, and after that, I'm going to decrease the right by 1. Right. So after this, we're gonna have 1, 10, 2, and 9, right? So in this case, assuming k is equal to 4, that's how we get 4 numbers here, right? And with k is equal to 4, we have like 3 different difference values, right? We have 9, 8, and 7, right? And then from here onwards, we're gonna print the remaining ones, right? So we have the remaining ones n minus k, right? That's the remaining numbers we need to add to the answer. And yeah, I'll just use like a most straightforward way. So I'll just check if the k is an even number. It means that we're gonna print the remaining in the decreasing order, right? And I'll just do this while remain, and then we have answer dot append dot right, right? Because it's a decreasing order, that's why we're gonna use the right number. Decrease by 1 and the remain decrease by 1, right? Else we're gonna I'll just copy and paste. I know the code is not that simple, but I'm just trying to show you guys the idea. At least my way of solving this problem. There must be some like more elegant or more concise way of solving this problem, right? I'm pretty sure there has to be one there. I know my code is a little bit long here. So else, right? Else means that if the case is odd numbers, it means that we have to reconstruct, append the remaining ones in the increasing order, which means I'll use the left variable here, right? and still we're gonna print add the remaining number of times, right? And in the end, so just return, right? Return the answer. Yeah, that's it, right? So run the code, accept it, right? Submit. Yep, so it works, right? So obviously, time complexity and time and space complexity, they're both all of it, because we have a for loop and here is a remaining one. Yep, I think that's it, right? That's it for this problem. You just need to have basically you just have to maybe try a few examples, and then to find the pattern, right, for this problem. And after that, it's just like which way is much matter of the implementations, like what kind of implementation you can use. I'm just using like the most straightforward way. Basically, I'm just like write down my solutions, from step one to the last step. There has I'm pretty sure there are like some like more elegant way to handle this kind of problem. Anyway, I'll stop here and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.